Hallo daar. Ons kyk nou na arbeid, energie en drywing. Work, energy and power. It's a few new concepts with a few new equations that they can use. Nou kom ons sê ons het 'n voorwerp wat getrek word deur 'n krag in 'n bepaalde rigting. It's pulled in a certain direction and that direction is parallel to the force. That is the one case. Another case would be, we have an object with a certain mass, but it's now pulled at an angle over the surface. Hy word nou teen 'n hoek oor die oppervlak getrek. Hier is die verplasing soontoe. Nou, dink 'n bietjie daaroor. Only this component actually draws the thing to the right. Net die horisontale komponent trek die ding eintlik na regs. Hierdie vertikale komponent van die krag het geen invloed nie. Hy trek die ding eintlik net boontoe. Maak dit bietjie makliker om te skuif. Hy lig hom op. Nou, arbeid word bereken deur die produk van die krag maal die afstand, delta x. En ons skryf dit as V is like aan F delta x. Daar's nou nog ietsie. Daar's nou nog die hoek tussen die krag en die verplasing. Cos theta. Daar's die fancy hele vergelyking. That's the whole equation to calculate work done. Nou, goed. Hier is daar die hoek 0. Theta equals 0. So cos theta equals 1. So it's just in that case, when the two are parallel, the work is just the force times the distance, times the displacement. So as die twee kragte parallel is daar die hoek 0 en dan is cos theta dan 1. So dan werk die arbeid net uit op F maal delta x. Sê maar dis 3 Newton maal 2 meter is 3 maal 2. And it's measured in joule. Joule. Werk word gemeet in joule. In hierdie geval is dit weer is like aan F delta x cos theta. Nou kyk nou, ons meet daar die theta altyd anti-kloksgewyse vanaf die verplasing. Baie belangrik. It's measured anti-clockwise from that displacement. So if it's 30 degrees, it would be F delta x cos 30 degrees. If the angle between them is 30 degrees. Good. Let's look at different angles just on the next page. What if the angle is a certain, if they're in the same direction between 0 and 90 degrees? Between 0 and 90 degrees, it's just this displacement and this. Naught to 90 degrees. So they're pulling in the same direction as the motion. Hy beweeg in dieselfde rigting as die krag. What if the force is between 90 to 180 degrees? As die verplasing nou, as die krag hiernatoe is, hier is ons voorwerp, en hy verplaas in daardie rigting. So this would be F, and that is the delta x. Then we use the same equation. F cos, let's say this is 110 degrees, or 120 degrees. F cos theta is like F cos 120 grade. And you will notice, sorry, times the delta x. Let's put the delta x there. Delta x times delta x, the displacement. So it's this F times the displacement times the cos of that angle. En jy gaan nou sien, jy gaan 'n negatiewe antwoord kry as hy tussen hierdie is. Hy val in hierdie kwadrant waar cos negatief is. So dit gaan 'n minuswaarde vir jou gee. Glo net die vergelyking, moenie worry of daar nou krag, wat se arbeid word nou op wie gedoen nie. Kyk net na wat die antwoord wat hy vir jou gee. Jy meet kloksgewyse bloot altyd vanaf die verplasing na hier af. Even if the angle is like this. Nou is hy groter as 180 grade, sê maar by 300 grade. Hy is nou weer in 'n kwadrant waar kos negatief is. It's easy also to see if the displacement is in one direction and the force is acting in the other direction. The cost will always be zero, minus a negative number. Hulle werk, as hy in hierdie kwadrant val of in hierdie kwadrant, gaan die kos altyd 'n negatiewe waarde vir jou gee. En in die laaste geval, if it's in this quadrant, if the angle is here, hier is jou verplasing en hier is die krag na delta x. Meet weer getrou vanaf die verplasing kloksgewys, anti-kloksgewys hiernatoe en dan kry jy dis tussen 270, sê maar as 300 grade of so hierso. En nou, jy kan sien, hulle is nou al van dieselfde rigting. They both pulling in the same direction, so in this case your answer will be positive. So whenever it's in this area, the answer will be negative and there it will be positive, the cost. But just simply, whenever there's a calculation, look at which direction the displacement is and then measure clockwise, anti-clockwise from there until you get to the force. And then you can work it out there. Daar is so voorbeelde daarvan op bladsy 45 in die tweede kwadrant of in die vierde kwadrant. In die eerste en die vierde kwadrant is hy positief, in die tweede en die derde kwadrant is hy negatief. So in those quadrants, the answer is positive. They're more or less in the same direction. In this quadrant, it's negative. They're in opposite directions. The displacement is that way and the force is this way. Wat van, sê maar die krag is loodreg op die verplasing. Hier is die verplasing nou soontoe en die krag is boontoe. Soontoe en boontoe. Nou, dis is wanneer jy 'n tas sou dra en jy loop in daardie rigting. Jy trek die tas op, maar jy beweeg in daardie rigting. So jy doen eintlik geen arbeid op die ding nie. You're actually doing no work on the thing because you're pulling it up, but the motion is that way. Work is only done when the force is assisting the motion or opposing the motion in some way. Pulling it up doesn't do anything to it. So, and your equation will tell you that. Is gelyk aan F delta X cos 90 grade and cos 90 degrees equals 0. So the answer is going to be 0 joule, just to get all your marks. Nou dit is die hele, of as hy gedra word, daar bladsy, nou het ons bladsy 45 afgehandel. Dit is die definisie van arbeid en as hy teen verskillende hoeke werk. If work is done at different angles, how is the work calculated? Now if there are different forces, in the book, they start off with this one. You've got an object there, it's being pulled in this direction, but it's got a weight, it's got a normal force, and there might be some friction also. If friction, and this is the applied force, this is a normal force, and this is the weight. Now you can work out each of these, what the work done is. Hierdie een is in 'n hoek van theta. Nou daai een, kom ons begin hier so by, so 1, 2, 3, 4. Ons kyk wat sê die vergelyking vir ons. By die eerste een, hierdie een, 1. The work done equals, so ek daarom nog op die bladsy, ja. F delta X cos theta. Nou F is T, and delta X is delta X. And the cos is just this angle if it's 45 degrees or whatever. Cos 45 degrees. Okay. En hom kan mens uitwerk. Hulle gee gewoonlik vir ons die een of daai een, dan kan jy die werk uitwerk. Die tweede een is nou hier na boontoe. Die work done equals the normal force, which is equal to M times G, the weight of this thing, and the mass from the mass, times delta X, times cos 90 degrees, which is 0. Okay, this little guy, the F, because of friction, equals the value of friction, the F there, which they will give us, of friction. Let's put this, the F, friction, let's say FA, times delta X by times, now you measure the angle from the motion of, the direction of motion, let's say it's being pulled in that way. I didn't say that, but it's moving that way now. And then the times cos 180, which is minus 1, if you put that in your calculator. So it is minus FA delta X. Let's say F. The work done is the force of that. Sorry, ek het hier 'n bietjie gefumble. Die werk wat gedoen word, die krag maal die verplasing maal die kos 180 grade en daai antwoord word gemeet in joule. Die weight is ook dieselfde, hierdie ene van die work is gevolg van die friction. Die work done because of the weight equals mg, dis die gewig, maal delta x, mg times delta x times cos 270 degrees, which is 0 joule. Just to put the fine point in it like that. Joule. Always make sure afterward, when you've done all the calculations, that you've put in the units, because you can do the whole calculation and have your sum wrong and you lose the mark because of the stupid unit. Okay, let's stop this lesson here and we'll continue in the next one.